By now, hopefully, you have a good grounding in what objects are. It's a representation of a thing, normally from the real world, could be a concept that I want to model inside of my software because I need to store data about it and I need to have that have some behavior around it. Now, those simple models work really well for us on really simple solutions, but at some point, our models are not as complex as the real world. The real world is full of variances. It's groupings of things. And some things behave a lot the same, but then have their own unique characteristics about them as well. And that's where we enter the value of inheritance. So trying to understand the value of inheritance implicitly, we have to understand what we mean by inheritance. Now, you think of the word inheritance, you think of some rich relative that you're going to get a bunch of money from. You know, your uncle, your aunt, your grandma, your grandpa, your parents. They're going to, unfortunately pass along and then they'll leave something to you. That's an extrinsic form of inheritance. That's stuff that I'm getting from them. That's not what we're talking about when we're talking about object orientation. When we're talking about inheritance and object-oriented, think more intrinsic inheritance. Less about the money and the furniture and the family heirlooms they have, and more about the genes they're giving you. Your tendency to be tall or short, or light or dark, or receding hairline, as it says there. That's the idea behind inheritance. It's what you're made up of. You get, and biologically speaking, half from your mother, half from your father, but then there's some that comes from other people as well. That's the concept we're going to be working on. It's an analogy. Don't take it too literally, but it's going to help us understand the view of inheritance. Now, the fundamental concepts behind this comes into this concept of generalization, specialization. We can talk a lot about categorization and get into that theory, but for our purposes, we want to group things up in some ways that they're common. And by generalizing groups of things, we're saying, what do they have in common? So if you look around, just say the classroom here. We're not all physically in the classroom, we're watching recorded, but if you look at the class roster, there's some things that we all have in common. They're right there on the screen. You have the name, first name, last name, you have student ID. Each of you has some sort of background that you might have put up there if you're looking at the profile page. That generalization is things that are in common for everybody who's a student of CTU. But if you generalize past that, what's in common with all students in general? Well, they might not have a profile page. They might not have a student ID. But they still have a first name and last name, right? There's things that's true for all people in general. And so, for example, again, let's take the examples here. Generalizations. We can talk about all things all dogs have. They have how long their ears are, short ears, long ears. They have a tail or not, how long their tail is, how tall they are, how long they are. They all do things in common too. They bark, they sit. Now, they bark different ways. We'll get to that in a little bit later. But that's all things that are common for dogs. It works for abstract concepts as well. We talk about a product. You say, go buy a product. Well, it has a price, and it has a description, it has a name, it has the ability to be purchased. It does stuff. You can buy that thing. You can ship that thing. Things that might be in common. That being said, generalization is only useful with specialization. Specialization is the way of saying, okay, I have these generic things, but give me one of them. So right now, somebody please go buy a product. Well, of course you know what I mean by that, but you can't go buy an abstract product. You have to go buy a thing. You can buy a book, you can buy a CD, you can buy food, you can go buy a car. Those are all forms of a product. I have to get to something more specific. And so the categories within the specialization, everything that's true for the generalization is also true for them, but there are more details as well. So within that general category, I can add specific things like dogs. If I have a purebred dog, it has specific paperwork that goes with it. And I might have specific types of purebred dogs. I can talk about Dalmatians, which have some number of spots on them. If I have food products, which is a specific type of product that has an expiration date. We'll get into this more, but conceptually, that's what we're talking about, generalization, specialization. Generalization is basically more inclusive. There's more things that fit into the category, but there's less detail about those things. Specialization is a lot more detail about the things, but they're not as inclusive in what can be categorized that way. And so again, this is all about categorization. And we're going to use that for our modeling here. So let's get a little bit more practical on this. Let me show you a picture now. So we see dog. And all dogs have name, color, and weight. And so if I have two different specializations of dogs, I have mutts and purebred dogs. Again, I could model this in a number of different ways. I can have different type of pure breed dogs. I don't know if there's many variations of mutts, but you can see in green there, all mutts have a name, color, and weight, just like all dogs do. All purebred dogs have a name, color, and weight, just like all dogs do. They're in common across both of them, but then there's stuff that's more specific. What different breeds are part of a mutt? My mutt is part beagle, part terrier. That's different things that go in there, as opposed to a purebred dog. I don't have a purebred dog, but they might have some AKC papers that go along with it, some numbers, some information that goes with that. Likewise with a product. All products have a name and a price. A music product, of course, has a name and price because it's a product. And then you have the artist that plays the music, that performs the music, and then the duration of the song. Food, again, we added an expiration date like we saw before. So those high-level things, those abstractions, are up top, and then the more specific things, the mutt, the pure breed, the food, music, the food, those inherit from those abstractions. So the generalizations up top, the specializations inherit from them. They get those categories, they get those details that come down. Now, in computer programming, we have a specific language that helps us do this. It's called UML. You've probably seen this before, class diagrams. And in the class diagrams, we have the special relationship. You see the little triangle here. Now, this triangle is very specific. It's an open triangle with lines that are coming off of it. This means inheritance. And it has to be drawn exactly like this. An arrow is not good enough. It has to be this triangle here. And so there's two types of dogs. This is how we read this category. This diagram, this is called the class diagram. For those of you who might not remember, I have a dog up here that's extended. We'll see that term come up by a purebred dog and a mutt. Those are both types of dogs. And notice the language I'm using. I'm trying to be very careful. These are the words you want to start using when we talk about this. We have a product. There's two types of products, music and food. But there's also different types of music. There's digital music and then there's live music. You can see a concert is a form of live music. Digital music, we have downloads and CDs. So this is the way we talk about this stuff. This is the way we can go about this. And so we extend to expand out the information we know about that thing. We start off with the product, name and music. We enhance that and say we have a music product, artist and duration. Then as we get more specific, digital, we'll come back to that. There's nothing added there. But then CD, we know what tracks are on it. And the box set is what CDs are included on that in that box set. And so we are adding more information by expanding it out. We're getting more specific. Not every CD is a box set, but every box set is a form of music. At least as far as our model goes here. You can talk about, maybe a comedy album or something like that, but it's the way we're modeling it here. So the syntax we want to be aware of is we still have the base UML class diagram. The class name goes up here, product. The attributes go in the middle box. The method name goes in the bottom box. What we're added in here is the triangle. And then again, the triangle is most important for showing this relationship. Two classes, a line between two classes shows a relationship. This class inherits from the product class. We'll see the ramifications of that. So right now, as you're watching this, I want you to do an exercise in your head. Think of the different subclasses of a person. So go ahead and pause the video right now. I know you're sitting there watching recorded. Pause the video and think of that. Draw it out a little bit. All I want you to do is draw a little triangle right here, put a triangle underneath here, some lines underneath, and think of different classes. Pause it and then come back. Okay. Now you've paused it. And then now you've come back. And so we're going to continue on. So these are different types of people. It doesn't really matter the different types of people. These aren't necessarily mutually exclusive, but you can have some of them in there: athlete, artist, customer, taxpayer, student, parent, volunteer, contractor, employee. I could certainly be an athlete and a parent. I can certainly be a customer and an employee. You have to be aware of the modeling I'm doing here and what's going to be applied, because any of these, and probably 1,000 million more that you came up with, could be used. But the point of this exercise is context matters. When we focus our model into inheritance hierarchy, we're not trying to capture every detail. I don't need to say Tony is a human, Tony is a teacher, Tony is an employee, Tony is a student, Tony is I'm all those things, but what am I for this application? For this application, my job is to buy stuff. So I'm a consumer. I might also work for the company, but it doesn't matter. My account is to buy stuff. Unless I have some special status that I can do both, that may be a special class to do there. We want to pick a worldview and model that. Now, we'll not get a ton of time to look at this, but we're going to kind of try and look at this as we go through some of our exercises and some of our modeling. But think about that as we go forward. We need to pick for your application that you're going to be building, what am I trying to do? And what are the classes that mean the most? All right, so that's a foundation in inheritance. We're going to continue talking about how this works a little bit, but take these concepts and then we'll build from there.